You've probably heard or read in tutorials and articles that composition is the way and should be used in place of inheritance. Both inheritance and composition are ways to create relationships between classes in object-oriented programming. We covered inheritance in detail earlier in this series, so if you need a refresher on that, I recommend that you watch that video first. In this example, we have an invoice class with a create method that accepts line items or entries of the invoice as an argument. Its purpose is to create an invoice, but before that it calculates line items totals, it calculates the sales tax, and then does some other things, and finally it creates the invoice. Of course, in a real application it would do more things, but we're going to keep this example super simple. That's why you don't see a lot of the code written for the create method. The line items total is simply calculated by calling array map on the line items array, which multiplies the unit price of each item by the quantity, and then it runs array sum function on the resulting array. For the sales tax calculation, we are hard coding the rate to 7% because I want to keep this example simple. And finally, to test that everything is working as expected, we are echoing out the results. If we open the public index.php, we see that an array containing 3 line items is being passed into the method. Let's test this out quick. Let's open the terminal and run the code. And sure enough, we see that everything is working. While this code works, there is something that does not sound or look correct to me. We have an invoice class whose purpose is to create an invoice and do things related to invoice. Is calculating sales tax the job of the invoice? Some might say yes, but I disagree. What if we had another class like a payment class whose job was to process payments? It could process a payment for the given invoice, or it could process a payment without an invoice, but it would also need to calculate the sales tax in certain situations. The sales tax calculation logic would remain the same, right? So our first option would be to duplicate this code right here over to the payment class or any other class that would need the sales tax calculation. But duplicating code over is not ideal because we try to follow the dry or don't repeat yourself principle. The next possible solution is to use inheritance to reuse the code. So we could create some sort of sales tax calculator class and extend it within the invoice class. So we would do invoice extends sales tax calculator, and we would simply move this from here into the sales tax calculator class. Now we have gained access to the calculate sales tax method, and in fact we can actually rename the calculate sales tax method to simply calculate because we have the sales tax within the name of the class. So it's redundant to have sales tax in both the class and the method names. So we'll just call this calculate. As you can see, we have gained access to the calculate method and we're able to use it within our invoice class. And not only that, we could use it in any other class like payments class or any other class that needs to calculate the sales tax by simply extending the sales tax calculator there. While this looks like a simple solution at first, this is not the right way to use inheritance. We are using inheritance for code reuse, and that is not what it's meant for. This is where a lot of developers make mistake and use inheritance to reduce code duplication. I've done this myself in the past, and trust me, it's not good, and it becomes painful to maintain the code base down the road. First of all, we have introduced the tight coupling between the invoice and sales tax calculator classes. Second, we inherit all the public and protected methods of the sales tax calculator class. In this example, we only have a single calculate method, but in a real application, as you can imagine, this class would have more methods and more properties and so on. And all of those public and protected properties and methods would be inherited into the class that extends this class, in this case, the invoice class. Maybe we would need to calculate tax rate because we are currently hard coding it to 7%. So maybe we would have a method that calculates the tax rate based on the user's location or something like that. Sales tax sometimes is calculated not on the total, but on each line item separately based on the product code. So we might have another method here that would calculate the sales tax based on those line items, and so on. So as you can see, you could have a bunch of other methods here and properties that would be inherited into the invoice class, but the invoice class only cares about calculating the sales tax. It doesn't care to have access to all the other methods and properties. Another issue with this is that we still did not solve the original problem. Invoice class is still kind of responsible for tax calculation because it inherits that functionality along with many other things. Inheritance creates an is-a relationship between the child and the parent class. So by having the inheritance here, we're essentially implying that invoice is a sales tax calculator. But that phrase does not quite sound right or make sense. Is invoice a sales tax calculator? It is not. And this is the first indicator that we are using the inheritance the wrong way, because we're trying to create an is-a relationship where it does not belong or make sense. This is where composition comes in. Instead of inheritance, we can accept this as a dependency via constructor like this. So we'll create a constructor here and we'll simply accept sales tax calculator as a dependency. And we'll simply call the calculate method on the sales tax calculator object. We can get rid of the extents because we no longer need to use the inheritance. Now we are saying that invoice class has a sales tax calculator class or has an ability to calculate sales tax. Composition creates a has-a relationship between the classes. We can inject the sales tax calculator class in payment class constructor or in any other classes constructor that would need to calculate sales tax, which lets us reuse the code without using inheritance and without duplicating anything or inheriting any unnecessary properties or methods. If for whatever reason we wanted to create a custom calculate method to calculate the sales tax within the invoice class or within the payment class, we could create that method. So we would create public function calculate. We could do some custom logic here and then proxy the original calculate method of the dependency. So we would do return this sales tax calculator calculate total, and of course we would accept this total either by argument or calculated within this custom logic or something like that. And this doesn't even have to be called calculate, it could be called anything else. So now the question you might be asking is, how do we decide when to choose inheritance or composition? Many articles, tutorials, family members, friends, and even your cat might tell you to use inheritance if it's a is-a relationship and use composition if it's a has-a relationship. Even I mentioned to leverage inheritance if is-a relationship makes sense in the inheritance lesson. What I left out in that lesson is that there are sometimes cases where even when is-a relationship makes sense, the inheritance could still be a bad idea. The example with the invoice and sales tax calculator did not have the is-a relationship, so it was easy to decide that inheritance was not the right solution. But what if we're working on classes where is-a relationship makes sense? What if we have two payment classes, credit card payment and bank or ACH payment? They do share some common functionality, so we might decide to create a base payment class and then extend it in credit card and ACH payment classes. Because is-a relationship makes sense and inheritance seems like a good solution. Both credit card and ACH payment classes are essentially payments. 6 months from now, manager or customer comes in and says that we need to start accepting crypto payments because it's cool. So now we need to create a crypto payment class, and we're kind of forced to extend the payment class because again, the is-a relationship makes sense, and we've already built out the base functionality in the payment class. The problem is that crypto payment class does not need or use a lot of the functionality that payment class provides. So we're forced to kind of hack it away by overriding certain methods and throwing exceptions to disable access to those methods, and so on. So it becomes a headache and we spend a lot of time refactoring to make it work. 1 year passes by and we're again asked to add another form of payment, and maintenance of such project becomes harder and harder. So inheritance basically makes you kind of predict the future. You design your parent class with all the behaviors or methods that you think will be needed in all of the child classes that extend this class in the future. And when that future time comes, you will find yourself having hard time maintaining and refactoring that code base. Let's do one more example, and you will like this one if you like or play video games. Say that we have different NPC types or different monsters available in game. We have alligators, dragons, and gorillas, for example. They all can move and attack along with many other features and abilities and bunch of other properties and so on. Now I left out, as you can see, the properties and some other methods. Just assume that it has a bunch of other properties and methods to make these classes work. The thing is, we right away see the code duplication and try to use inheritance here. We decide to abstract away the attack and move methods into some sort of base class that can contain the common functionality between these three classes. So we decide to create some sort of NPC class. So we extend the NPC here, and we extend the NPC in dragon and gorilla classes. Then what we do is that we move the attack and move methods from here, and from here into the NPC class. And we can make this an abstract class. It doesn't have to be an abstract, but it makes sense to be abstract in this case. Now, of course, the alligator, dragon, and gorilla could override the move and the attack methods to handle the movement and attack in a specific way, but the base functionality would still be there. The base attack method would still be there. And also, some of the properties and other methods that they might be sharing could also live in the NPC class, like the HP or the mana or some abilities and so on. So as you can see, we have reduced the code duplication by using inheritance, and the inheritance checks out here because is-a relationship makes sense, since all of the three classes, alligator, dragon, and gorillas, are NPCs. So everything is going great. We build the custom functionality for each NPC, and some time passes by and management comes up with a great idea that we need quests in-game. So we need quest giver NPCs. That means that we need to create a quest giver class and extend the NPC base class in there. So we'll open the quest giver class here, and we are extending the NPC. Because quest giver class is also NPC, and it can also do certain actions that an NPC can. It shares some common functionality with the NPC, so it needs some of the methods and properties that the NPC class provides. So we build out the custom functionality in the quest giver, and everything is going great. The problem is that quest giver class should not be able to attack. But yet, our parent class provides that functionality because we're inheriting the NPC class, which has the attack method. So we have the base attack functionality in the quest giver class. We can't have quest giver NPCs attack. So what do? We override that method. So we'll override the attack method here. And instead of doing some custom functionality here or custom logic or even calling the parent attack method, we throw some kind of exception. So we'll do throw new runtime exception, quest giver NPC cannot attack. This way we are trying to disable the attack functionality on the quest giver class. This right here is another indicator that inheritance might not be the right solution, because we're forced to throw exception to kind of disable certain functionality. We only just got started and are already having to do things like this to make our code work. So what do? We double down on inheritance and create a monster class that extends the NPC class. So we'll open the monster class and we'll make it extend the NPC class here, and we'll move the attack method from the NPC into the monster class. Then within the dragon, gorilla, and alligator class, instead of extending NPC, we'll extend the monster class because we need these classes to have the attack ability. And within the quest giver class, we can leave it extending NPC because it does not need the attack ability. And we can get rid of this overriding method and throwing exception because we no longer have the attack method. Now we think that we've solved the problem and move on with our day. Some more time passes and our management comes up with another great idea.
Another brilliant idea. A special idea.
We now need to add pets in the game that player can have. So we create the pet class and extend the NPC class. So I'll open the pet class here and we'll simply extend the NPC. And of course the pet class has its own properties and methods and maybe override some methods and so on. The problem here is that pet should be able to attack because it can help the player with fighting monsters, and because we moved the attack method into the monster class here, we no longer have this method available on the NPC, and therefore pet class doesn't have the attack method. So we kind of have to duplicate this method over to the pet class. You might be saying, why can't you just extend the monster class here instead of the NPC class? And the answer to that is because is-a relationship doesn't make sense, because pet is not a monster. Pet is an NPC that can help the player. It's not a monster that player can attack. So in the end, we are left with some duplication, because the alternative would be to do something worse and extend monster in the pet class, and that is not something that we want to do. And you probably see where I'm going with this, because more time passes and the new features and changes are constantly requested. For example, we might have to make some monsters be able to swim, some monsters be able to fly, while some can both fly and swim, and some monsters may not even be able to move and are stuck in place. So doing this hierarchy and extending things becomes difficult, because we have to either disable some functionality like we did before with the attack method, or we need to duplicate the things over, or we would do something worse and extend the wrong class. So as you can see, even when is-a relationship makes sense, the inheritance might not be ideal. Inheritance kind of predicted the future here when we started out. We were assuming all of our NPCs would be able to move and attack, but later we found out that some can't attack, some can't move, and so on. So composition would be an ideal solution here, because we could extract these methods or behaviors into their appropriate classes and inject them via constructors where needed. So does this mean the inheritance is bad and we should never use it and should always use composition instead? Some will say yes, but I disagree. I think inheritance has its use cases if used properly and when it makes sense. I basically do a few checks before I decide to use inheritance. Does the relationship between the parent and the child represent an is-a relationship? Are there any unnecessary methods or properties that are needed in parent but not needed in child class? In other words, am I going to be hacking things or overriding things to change or disable functionality? Are classes substitutable? And so on. In most cases though, I go for composition because it is what makes sense. In addition to that, writing unit tests when using composition is much easier. Before we wrap up this video, I want to mention that in some cases when using composition, it makes sense to use interfaces. If we go back to the invoice and sales tax calculator example, and we open the sales tax calculator class, what if we were using some third-party service to calculate our sales tax instead of hard coding things here? So what if we had some kind of constructor here and we were injecting a third-party service like TaxJar sales tax service, and we would of course promote this, and then instead of doing this, we would proxy that call to the API. So we would do this API calculate and pass the total or whatever we need to pass. Now the problem with this is that we have a generic sales tax calculator class and we're injecting a very specific implementation or a concrete implementation of a sales tax service. So instead of being specific here and instead of type hinting to a concrete implementation, we would type hint it to some implementation of sales tax service instead of being specific. So we would do sales tax service interface, and now sales tax calculator does not know the specifics of what service we use. It knows that we're accepting some sort of implementation of this interface, and then we would implement this interface in the TaxJar sales tax service or any other service that we might use in the future. We talked about this a little bit in the interfaces lesson as well, so you can check that out if you haven't watched it already. So this is it for this lesson. Hope you enjoyed it. If you did, please give it a thumbs up, share and subscribe, and hit the notification bell icon to make sure that you don't miss any of my future videos. If you have any feedback or comments, please post it below. And as always, I'll see you next time.